Hello everyone. I came across a situation where my son was not able to understand the concept of congruence. He was facing some difficulties. I taught him, he was able to understand. Later I realized, why can't I share this knowledge to all the students, whoever facing this as a difficulty, and they can learn from this. So this is a small initiative from my side. Let's jump into the topic. Okay, I am reading from 7th standard CBSE book. Every figure has a shape, size and position. Okay, if we are given two figures, if both of them having the same shape and size, then we can say both of them are congruent. For example, if you see this two triangles A, B and C and X, Y, Z, if we cut this and keep like this, keep one over the another like this, I am just placing this like this, it's exactly matching. So consider this as a plane, okay, it's a 2D plane. If we are keeping some objects over another objects, shapes over another shape, if it is exactly matches in size and shape, that is called as congruent triangles. These both are congruent to each other. Not only this, we can even say, like, for example, 2 rupee coin is there. So one over the another, if we place exactly like this, we can say that both are congruent. This method of keeping this is called as superposition, one over the other. If it doesn't matches, then both of them are not congruent. So congruence, these are some examples. Both the lines of same length, we can say both are congruent. If angles between two lines are same, if two squares exactly matches, if two rectangle exactly matches and two circles having the exact same radius, so we can say both are congruent. If two triangles are congruent, we use this specific symbol, that means equal to and then like this tilde. That means ABC is equal to, is congruent to DEF. So we can understand from this simple, that is whether they are asking to prove both of them are congruent or not. Coming to congruence of triangles. So here two triangles are there, ABC and DEF. If it is given like this, single line and single line, that means both of these are equal. That means AB is equal to DE. So that is the understanding. If two lines are given, so AC is equal to DF. And similarly for the third one, if it is given like this, three lines, that means this line and this line are of same length. That means BC is equal to EF. Okay. So this is the basic understanding here. So we can say both of them are congruent. Even the angles also remain same. Angle A is equal to angle D. Similarly angle B is equal to angle E, and angle C equal to angle F. Now let's see the four different cases in congruence triangle. Triple S, S, that means side, side, side. The very first letter we are getting here. Second one, SAS, side, angle, side. Okay. And third one, angle, side, angle. You can see here, angle, side, angle. And fourth one is RHS, right angle, hypotenuse, side. Coming to the first thing, S, side, side, side. That means if, as we saw early, if the sides of the triangle are equal, that means AB is equal to DE, BC equal to EF and AC equal to DF. All these are equal, that means these two triangles are congruent, we can say, based on the first rule, that is side, side, side. Now considering the second case, side, angle, side. So consider these two triangles, side, angle, side. It's very easy. There are two sides. and there is an included angle. Okay, there is an included angle. This is side 1, this is side 2. Okay, similarly, it has got one angle. This is side 1, side 2. So what the rule says is, if two sides of a triangle, first triangle, and its included angle in between these two sides is equal to two sides of another triangle and included angle is equal, means we can say both this triangle are congruent. Forget about AC and this part. This could be like DEF. Forget about AC and DF. We are considering only the two sides, AB and DE and BC and EF, and the angle in between them. If these two are equal, we can say that these two triangles are congruent. Now coming to the third case, angle side angle. The rule says two triangles are congruent if the two angles and the included side of one are equal to two angles and the included side of other. That means we have two angles here, B and C. Here E and F. Here B is equal to E, 50-50, and C is equal to F. So if two angles, okay, two angles of first triangle and the second triangle are equal and the included side, that means this one, BC, this is equal to EF. Okay, EF. If these are, consider this as a 4 centimeter and this is also 4 centimeter, then we can say these two are congruent. There might be cases angle will be equal but the distance may vary. In those cases it is not congruent. It has to satisfy all the conditions. Both the angles should be equal and the included line within that angle. Okay, within that angle, this is the included line, not this line or this line. If these two are equal, then we can say both are congruent. Now coming to the fourth case, RHS, right angle hypotenuse side. You can easily remember this. That means two right angle triangles. What is a right angle triangle? The angle will be 90 degree here, perpendicular to this AB is perpendicular to BC and D is perpendicular to EF. We have a 90 degree here. Okay. So two right angle triangles are said to be congruent if the hypotenuse is equal and also one of the side of the hypotenuse, either this DE or AB, DE equal to AB or BC equal to EF. Any one side is equal means we can say both are congruent. That means if AC equal to DF, AC equal to DF, hypotenuse, this is hypotenuse, and any one side, here in the figure it is given as this is equal to this. That means AB equal to DE. So this is a side. Okay, and we have a 90 degree. This is a right angle triangle. So both are congruent because it's satisfying two conditions. Hypotenuse is equal as well as the side, one of the side is equal. Okay, let's take this example sum. Given PL is perpendicular to OA, that means we have a PL here that is perpendicular to OA. This is 90 degree. Okay. Similarly, PM is perpendicular to OB. PM we have here, OB we have here. This is perpendicular to, PM is perpendicular to OB. This is 90 degree. They are asking whether PLO is congruent to PMO. That means PLO, this triangle, is congruent to PMO, this triangle. Whether both are congruent, they are asking. So we need to think about the four scenarios. Using which scenario, which case we can solve this problem. Because we immediately identified these two as right angle triangle. We have four conditions, right? The fourth one is RHS. Yes, you are right. Right angle triangle. Using that case, we can solve this. So, what is this given here? Right angle triangle case is hypotenuse. This is common here. Oh, in both the cases of triangle, OP remains common. So, OP remains common. So, hypotenuse is equal in both the triangle. Second case, this is a right angle triangle, any one side of each triangle, right? Here they are already given PL is equal to OB, sorry, PL is equal to PM. Yeah, I forgot to mention that, they have given that in the question itself. So these two are equal. So we know clearly one side PL equal to PM, one side is equal. So based on the fourth condition, we can say this PLO is congruent to PMO. That's it. Coming to another example, we have something called parallelogram. ABC and ADC, two triangles. Okay. So here the given data is AD equal to BC. That means AD is equal to BC as well as AD is parallel to BC. Both of them are parallel to each other. That's the given. So they asked to prove ABC is congruent to CDA. This triangle ABC is congruent to CDA. So let's think about four conditions. Let's try SAS, because we know that if you see this here DACB, just I transferred here. This angle is equal to this angle because we know that alternate interior angles are equal, right? We have studied in the previous classes. Alternate interior angles are equal because AD is parallel to CB. Okay, AD is parallel to CB. So if something like this is there, this may vary. It will not be equal. Since because it is parallel, so this angle, alternate angles are equal. So we can say like this angle is equal to this angle. Okay. Now they already given AD is equal to BC and angle also equal. So this AC remains common here. So if you take SAS condition, so AD equal to BC side and DAC angle equal to ACB. Okay, that means angles are equal. Okay, angles are equal. And then third condition, third thing, we have AC. This AC is common. Common to which triangle? Both the triangles. This is common. So we can use SAS condition. Side angle side. That means side angle side. We read, right? So two sides and in between angle of one triangle is equal to two sides. This condition, two sides and in between angle are equal. Hence it's proved that ABC is congruent to CDA. That's how we should solve the problem. First thing is identify the problem, what details are given and based on which condition, whether condition 1, 2, 3, 4, SSS or SAS or ASA or RHS, based on that, and the concept of already learned something like alternate angles are equal. Those things we can apply and solve the problem easily. All the best. Thank you.